Okay, guys, welcome back to another episode of the Real Hacker Hours podcast. Today, we're going to continue working on the static bug finder. And what I'm going to want to do is continue working on implementing a new type of bug class for detection. That is the index array out of bounds, such as what we're seeing right here. We see here that's passing, well, it's referencing an index here, and actually, I'm going to want to change this a little bit. Actually, I won't change the source code right now, but effectively, the check is for buffers of a static size that we can actually determine statically. So that being stack buffers and buffers in the global variable sections, and there's a variable index. I want to check to see if that can actually be out of bounds. First thing that I did was, in the previous videos, I upped the detection for, oh hey, is this buffer actually in the stack? Next thing I need to do is determine if the index is a variable, and the third thing I need to do, and this is going to be where most of the new functionality comes in, is detecting like the constraints on the checks that I need to pass in order to get to this specific piece of code. So for here, it would need to recognize that, hey, in order for this line of code to execute, I would need to be less than 50, and that's where I think the next like big boost in useful functionality will come from. So continuing on, we have here, this is the P codes for the function, and let's take a look at them. Int add conditional branch. Here's where the if then check for the less than 50 is, the one right here. If conditional. And here is the code that corresponds to this line of code. Signed extend. This is probably getting, oh yeah, this register OX30, that is you can tell it that it is because it's using the comparison right here, and it's being loaded into, signed into that one. Adding, what is register OX30? I get the feeling that's a stack pointer. No, that's not the stack pointer. Oh, register OX30, that's probably, considering that OX30 is the, that's probably the input argument, and that makes sense because adding it to the input argument to get this unique. OX47. Casting it. I forget what casting does. Oh, wait, a casting is effectively a copy. However, it deals with a difference in type. It does some sort of type conversion, and then it's loading a byte from there into here, into this unique, which is then being stored at this address. Which, let's see, where is this being generated? Okay, for some weird reason, it's being stored here. But we see this pointer at yeah, I've seen this in several different instances where like the P code to generate this var node for the store is after the store opcode, which might prove troublesome with some of our algorithms, but it hasn't yet. So what can we do here? This is the P code that we are most interested in. Unique, what is this? Okay, here it is generating a, is where it's actually generating the base address for target. We can tell that. Now, we already have we already have functionality that when we look at this P code, we can realize that it's generating a stack pointer and storing it in this var node. And when you get to here, this is where we're actually going to like realize that, hey, this is an index to a stack buffer. We can recognize that by the fact that we know this is the base of the structure, which we see from the previous instruction. is a stack, what do you call it? A stack buffer. And here we see this is the number of elements, and this is the what do you call it? The size of each element, sort of like f reads number of elements times size of elements. Same thing here. Now let's go ahead since I feel that the check constraints is the bigger problem, I'm going to want to focus on that more, at least in starting. What I will do starting off, just for the detecting the if the the index is constant, this index being this, is I can just check the two size var nodes, this and this, and check to make sure that both of them are not constant. Now, this might not be absolute, well, in this case, it's a variable and only one of them is constant. But even if both of them are not a constant, we might run into a read scenario where, like, due to how the P codes are generated, it might be like a unique or something, and it can still be a constant. I don't know. I will have to further explore that at a later date, but for now, I'm just going to move forward with the assumption that if both of them are not constant, then the index is variable. But that will need to be checked out further later. So let's go ahead and go to pointer add, check for index out of bound. Okay, so this is checking for a looped increment array out of bounds. This is checking for an index out of bounds. So the index and the size of the index are what we're going to need to check first. So we get index and element size equals inputs of 2. Also going to just throw in a sanity check here to make sure that inputs is the minimum size that we expect it to, which would be 3. Actually, I'm going to quickly look up Ghidra. I know some of the P codes have a variable length, or can have like either 2 or words. Some P codes can have a variable number of inputs. So I'm going to look that up. Ghidra pointer add opcode. Oh, apparently, I'm looking at the docs right now. Apparently, input 2 is always going to be variable. Okay, yeah, so we only need to check the index right here. If index dot is if it is not constant. Okay, cool. If it is not constant, then we're assuming that the index is variable, so that's what we want to see here. I'm going to offload this to a helper function, the checking if it is not constant. Reason for that being is when I do the further investigation to see if like just doing that will actually be enough or need to do more, you may need to add additional functionality, and having it just in a helper function that I call will make that process a lot easier. Public void is var node constant var node source var node, or return source var node dot is constant. And we can go down here, pointer add. Okay, if we get to here, we are assuming that index is a variable. That leads us to the next problem, probably the biggest one that we have here, which is, what is it? It's the checks that we need to pass in order to get to this point. Now, this is the fun part. For here, we see that there's a direct comparison that this register has to be less than OX32, which I believe is, yeah, it's 50. Otherwise, well, which that value is set. And then we can see this conditional branch. If that happens, we jump down here. Now, how I plan on modeling this in memory is how I deal with conditional branches already is I fork two different like code iterators. One is if the conditional is met, another is if the conditional is not met. What I will do is I'm gonna with the code with the context, because each code iterator has a context. I'm gonna have like a hash map or something, some sort of data structure that effectively models that, like, hey, in order for this context to actually happen, this var node has to be less than a value or greater than a value, or like greater than and less than a value. I'll have to come up with that. Yeah, those things myself. And then that way when you actually see, like, when you get to this pointer add instruction, we can take a look at this register OX0A. See, where does this come from? This comes from here, which comes from this register OX34, which then, okay, just to reiterate what I'm doing. When you get to this pointer add operation, we realize that, hey, this value right here, that value will determine if this is a bug or if this is just safe code. So we can go ahead, take a look using the data structure we've already defined as to what var nodes feed into this. We will see that this var node right here feeds into it. Also, this var node and this var node are two separate var nodes, even though they have the same register name. Generally speaking, each var node will have just one definition. But yeah, we'll see that this var node feeds into it, and we'll see that, like, hey, this var node has a constraint on it, that being the constraint right there that has to be less than this value in order to run it. Now, for the actual data structure itself for a constraint, what I'm imagining I will do is I'll do a hash map where the key is a var node. That way, and well, the value is another class I'm going to make for constraints. That way, to check if, like, there were any constraints on, where is it? Pointer at this one right here, I can just use the functionality I already have of just iterating through all of the var nodes that feed into this one as input, and then just look them up in the hash map to see, are there any constraints on this? Are constraints cool? Get me the range of it, and the range of all of the var nodes together, whatever range will allow me to pass all of those checks, will be the range of what that value can be. Now that I've explained how I imagine doing this, let's go ahead and start coding this up. This is going to be fun. File Linux. We'll need to make a new file. Let's call this checks constraints, because that's realistically what we're more, even though the constraints are to pass checks, I think from a modeling standpoint that's really what we're trying to go for. So let's get set up here with a new class. I'm gonna just copy and paste all these imports, that way I just have it working. Class constraints. It's going to be public constraint. Now, how are we going to want to do this? We might have, so right now I'm only really worried about integer constraints. Gonna pause the stream for a second. Okay, cool. I am back. Let's get going. So what we're going to want for the constraint class, we're going to want, of course, well, let's first have a constraint type equals integer. How do I define types or constants? This is the wrong source code file. Okay. I'm going to define some enums here to make our life easier. Integer. Currently, the only type of constraint type we will have is integer. We might have to have other constraints such as a string or float or something like that, but for now I'm just keeping it to integer because most of the use cases I can imagine are that. Now, we're also going to need a integer max value equals, gonna set private static final int max not set. It's going to be equal to, what is the max minimum Java int size? I'm going to set it equal to integer dot min value and private final static int max. Oh, actually, this is going to be the max size. Max size and min size. Am I doing this right? I don't think I am. Oh, just int. Okay. After I get everything working, you do go through and make sure that I'm doing Java permissions right on the variables and the functions, because I'm pretty sure I'm not. Max value. Okay, so these two values are going to be used for integer comparisons. Basically, just say that, well, actually, first, the max size and the min size. Now, potential issue with this is there might be a scenario where valid values are like between 0 and 5 and 20 to 30. So basically we have set ranges, and in that case this is not going to cut, well, that's the right term. This isn't going to make the cut. Reason for that being is this only has a single range. As such, we're gonna maybe have to deal with that, but I think I want to wait a second before that. Also, to explain, for the max size, I'm setting it to the minimum Java value. That way, it's an enum which I can call upon just to check is the max size equal to min value. If it is, then we know it hasn't been set. That way, let's say there's only a maximum boundary. I can just check, oh, the maximum boundary is set, but the minimum boundary is not. So we know as long as it's below this max boundary, it is a valid figure. And lastly, another thing I'm going to do is I'm also going to store the var node that the constraint is on. Now, even though this constraint might apply to multiple var nodes in practice, we were only going to have it tied to a single constraint, but that won't be a problem since we could just iterate through all the source constraints and just see, well, source var node and see what constraints are on them, and just, well, yeah, we can like aggregate all those constraints together, how I'm imagining. So var node, source var node, wait, no. Constraint var node equals source var node. Okay, I want to go ahead and run this with it. Now, I'm going to make a symbolic link right now, where are we? Features, base. I think Phalanx is in here. Yeah, Phalanx is linked in there, along with context and code iterator. So I'm just going to go ahead and make a symbolic link to constraints. The reason why I'm making a reason why I'm making a symbolic link to here, Ghidra has set directories in which it will check for Java files, and by default it looks in the Ghidra example scripts directories that it does have. There is a way that you can change it. I don't remember what the way that you can change off the top of my head is, so I just use the default example directories for that. Now that that's loaded, let's go ahead and just run it once to make sure that just linking it didn't break anything. So constraints 49. Oh wait, this should be. And there's some issues in code iterator. 200 line 243. Yep, this is code iterator. Well, let's see what we have here. 243. I think that was the issue. Let's try this. No. Oh, this needs to be a boolean, not a void. That's the issue. Let's see, does it work? It works, good. Now, let's go to pointer. Actually, yeah, integer s-less is the, what do you call it? The P code that is going to be doing the comparison, so that's going to be where we generate the constraint. Okay, we're going to want to do something. So right here, I have code for dealing with a, so the s-less is for a sign comparison. The code I already have here effectively iterates to the var nodes, and if a var node is not constant, I add it to the list of var nodes that have sign comparisons done to them. Now for this, what I want to need to do is also just realized another potential issue with this is I'm going to have to compare var nodes against var nodes with other constraints, so that might prove to be a bit of a brain challenge, but for now let's just do constants. How do I want to do this? For now, what I'm going to do is, let's get the inputs of our node. Inputs equals current pcode.get inputs. And we can iterate through those inputs here, checking for signed comparison values. Now, here's the next part. The next part is a little bit trickier. I'm going to want to basically do a check to see if there is one var node that is not constant and one that is, because that makes our life a lot easier. So if var node input 0 equals inputs 0, var node input 1 equals inputs of 1. Let's fix this typo right here. We can just do if input 0 dot is constant and if input 1 dot is constant. Wait, no. Let me just write out the if statements. Else. So either of these loops will execute if one of the inputs is not constant and the other one is variable. What this gives us is this tells us that, hey, it's comparing a var node against a constant value, which is a type of check that we actually want to look at for now. Now, what we can do here is, let's do, actually, I'm going to first just run the code before writing any more code just to make sure I didn't break it somehow without realizing. Okay, it ran. Cool. Let's go ahead and make the constraints. C. Probably need to change this from constraints to a single constraint. Yeah, I'm going to go, just before it causes a bunch of problems, I'm just going to go ahead and just change this from constraints to constraint. File, save as constraint. Let's go ahead and remove constraints. And let's go ahead and remake that symbolic link. I love it how 3 of my source code files begin with CO. Okay, let's try this constraint C. Oh, I misspelled constraint. We have the constructor right here. Just make sure that works as intended. Okay, just gonna run it one more time, make sure that works. Keep making minor changes. I want to make sure that they don't destroy it. Okay, let's see. Can we actually declare a constraint data type now? I'm going to take a look. What is the... Oh, it doesn't call anything. It's just public constraint. I know how to code Java, I swear. But in reality, I don't. Okay, so that ran. So we have constraint C, and we can do C equals new constraint input 0. C equals new constraint input 1. Input 0 is the var node that's been constrained here, since that is the one that is not a constant, and this one is the var node that's being constrained since input 1 is not the constant there. And let's go ahead and just run this to make sure that doesn't brick the code base. Okay, so you see that ran, so that's successful. Now for the we have defined here that we have the constraint. Now we need the value being compared against, and if, well, let's first look at it. I'm going to pull up in Google the syntax for isLess. Ghidra. But actually, it's int sless, yeah. So for this, there are several things that we have to look at. We know that this is the variable, effectively the value that the constraint is being placed on. This is the constant, and this is the output. Now, what we first need to look at is this in the first or the second argument, because the actual output is set equal to if this first argument is less than the second argument. So we need to keep track of, is this in the first or the second spot? We need to keep track of what this value is, and we need to keep track of what the output var node is. That's just for the int sless pcode op. Immediately following that, there will be the C branch op, or pcode op, which when you reach that, the thing is, we should hit a comparison like that, and then immediately hit a conditional branch. Only case for that might not be is if we have just a boolean that is set equal to a comparison output and then used on later, but I'm going to worry about that later. So we could just have like a global variable in the context that's just the last comparison used. However, for now, let's just worry about this. Let's have a this is going to be a bit of a mind problem here, or yeah, fun thing to think of. Okay. So for this, what do we want to do? We want to keep track of, is this in the first spot or the second spot? So let's have in first input, second input. First arg. Second arg. I'm going to pause the stream for a second while I think. So right now, there are several different functionalities I have to worry about, but for now, I'm just going to focus on having the logic in constraint.java focused on generating the actual range that needs to happen in order for our code path to be executed, and it recording and being able to tell me that. Later on, after I get this functionality working, I might decide it's better to like migrate some of that functionality elsewhere in the code base, but for now I'm just going to worry about having that functionality here. So in addition to that, we're going to need min size, max size, int argument index. In addition to that, we're going to need to also keep track of what P code is what P code operation is used to compare it, because actually are all of these the same? Yeah, depending on what comparison it is, that's going to change the comparison between the arguments, and we're actually modeling it. We're going to need to have that information. So actually for that, I'm just going to use the Ghidra P code op just to keep it simple. Arg index integer P code op. I'm going to make some functions here. Public set arg index int arg index. This dot arg index is equal to argument index. That will be the first thing. Let's go ahead and run it. Okay, cool. That ran. Let's have the next function be, oh, wait, this needs to be a void. Let's go ahead and also write the function to set pcode op and pcode op. This dot, what do we call it? Pcode op is equal to pcode op. Let's go ahead and set, actually first let's run it and then actually go ahead and call these functions and print out what the opcode is, just to make sure that it is being set accordingly. Okay, that ran as expected. That's good. C dot set arg index. In this case, it's the first argument, so that's going to be 0. And the next one is going to be the second argument, so that's going to be 1. And then let's also set pcode op. What is going to be? It's going to be current pcode.get opcode. And then let's also set that here. And then I'm just going to print that out. System.out.println c.pcode op. Let's go ahead and run this. C code pcode op equals, I'm just going to initialize these to -1 and -1. What's going on here? C.pcode op. Okay, yeah, it's saying that C might not have actually been initialized, so I'm just going to go ahead and throw the print statement here. Actually, it might be better to gonna do something where I initialize the constraint to null, and these checks I will either if I need to initiate a new constraint and set the relevant stuff, and then have an if then condition here. If C does not equal to null, and this code can be here. The just generic constraint code. Okay, let's go ahead and run this. I'm not seeing this printed. I want to throw a print statement right here just to see if this is being executed. Might be good to remove the P-code printing output. Impressive. It'd be funny if this is in the... Yep, this is an iterate until call, just as I imagined. Pointer add. Now this is going to go in integer s-less. For a second I was like thinking, is that where that goes? No, it goes here. Let's go ahead and run it now. Just watch, there's going to be a ton of errors. Oh, need to establish inputs. Let's see, did it actually... Okay, it is actually, you're seeing the output right there, so that is working. Let's see. It's printing the opcode. Cool. So we have, well, what's the next step? So I think the logical thing here, we have the condition, also we also need to set the output. Source var node. Let's also set the var node output. Out var node. Var node out var node, and let's set that here. Out var node equals out var node, and we're going to need to var node output equals current pcode dot get output, and let's go ahead and set that here, and here, and we also need to set that oh, okay, those are along two places. We can set it then. Let's go ahead and run this. Now, what we have here is we have a check. We know the input to it, one being a var node, the other being a constant. Those are the only type of checks that we're modeling right now. And we know the output of our node, and we know the type of operation that is happening on it. Now, what we can do is we can have another hash map that is effectively like the output of our node to a particular check. That way, let's say we're iterating here, we get to this s-less, we can generate a constraint that, like, I want to say it's like a one that has not been realized, or not like an official constraint, and we just say that, hey, the value of this var node is directly dependent on this constraint which you modeled. And then we get to a C branch and we see that, hey, the conditional for here is based upon this var node. Let's look over the hash map. Okay, we have a constraint model for it. Let's actually see what the condition is for it to go either one path or the other path. And then from there, we can actually then say, okay, we're going down this path. This var node here that is used in the comparison has to be within this value. Okay, now we can actually mark that as an official constraint on this var node in this path. But this stream has been going on for over 45 minutes, so I'm going to end it here. Thank you for watching.